Okay. Now till now we finished. What are the things we finished? R, L, C, RL, RC circuit we finished. Now before going for RLC, the last circuit, we have to go for power. Power के बारे में we have to study. Okay. So we will see power in AC circuit. Okay. Power means, you know what? What is meaning of power means? Power means power है आपके पास? हाँ. Power. Okay. देखो, power means rate at which electrical energy is consumed in an electric circuit. कितना fast में electrical energy is getting consumed, that is called power. Okay. So इसका formula in DC में, what is the formula for power? In resistor में I am passing the current I. Power कितना होगा? याद है? Voltage I, voltage V है. So what is the power? VI. This is in DC circuit. DC current flow. So this is the formula we learned. And here 2-3 formulas we learned, right? V equal to IR भी लगाया. So I square R. और I equal V by R लगाए तो V square by R. We learned in current electricity DC में पास किया तो. The power consumed. How much fast electrical energy is getting consumed. Okay. But in AC में voltage and current is varying. AC का सर्क्यूट को देखा होगा ना, एवरी इंस्टेंट में वोल्टेज बढ़ता जाएगा, करंट भी बढ़ता जाएगा, ऐसा बढ़ता जाएगा. सो वी कैन नॉट से पर्टिकुलर वी आई. कौन सा वी है, किसका वी है? इधर देखेगा तो 220, इधर देखेगा तो 110, इधर देखेगा तो 100. सो बढ़ता जाएगा पावर. सो उसके लिए वी हैव टू टेक द एवरेज पावर. एवरेज पावर इन एसी सर्क्यूट, उसका फॉर्मूला लिखेंगे एवरेज पावर का. In AC में we have to use always, whenever they ask power, find the power means we have to find average power only. Okay. So average power का formula लिख रहा हूँ. P average is VRMS into IRMS into cos phi. VRMS into IRMS into cos phi. This is a formula for average power. In AC में always we have to use VRMS into IRMS into cos phi. And you know how to convert RMS to peak to RMS, you know already. What are the voltage in the question they given? That is RMS, until unless mentioned. Okay. And here, what is cos phi? Cos phi is called power factor. Power factor. And what is phi? Phi is nothing but phase difference. Very important. Phase difference. In purely resistance में phase difference between what? Phase difference between voltage and current. Okay. So in purely resistance में what is phi value? Purely resistance में current and voltage are in the same phase. So phi value is 0. Cos phi is, cos 0 is 1. So ऐसा we have to find the power factor. Phase difference के साथ. Okay. And same power factor RL circuit में कितना होगा? RL and RC circuit में कितना होगा power factor? RC circuit में सपोज इंपेडेंस ट्रायंगल मालूम है आपको? इंपेडेंस ट्रायंगल मालूम है ना? आरएल सर्किट का कैसे ड्रॉ किया, याद है वाला? आर एक्सएल and this is Z and this is phi. Phi is right. From this, what is cos phi? Adjacent by hypotenuse. R by Z is the formula. Okay. Similarly, RC में this is R, नीचे XC रहेगा, and Z is like this, and this phi. So what is cos phi? In this also, adjacent by hypotenuse. Adjacent by hypotenuse. So R by Z. So RL and RC में power factor will be R by Z. But remaining, Sadiq bolo, purely inductor circuit. Cos phi is how much? Purely inductor circuit. So voltage and current will be pi by 2. Cos pi by 2 is 0. That time power is 0. Average power is 0. Purely inductor circuit. Purely capacitor also power factor is 0. Purely resistance में 0 है. Cos 0 1. VRMS into IRMS. Okay. But RL and R combination में क्या आएगा? R by Z आएगा. Cos factor. Okay. So this is a formula we have to learn in this way. So what is the formula? P average is equal to VRMS into IRMS into cos phi. चलो, now एक एक सर्क्यूट का थोड़ा लिखेंगे कंप्यूटर. So tell me, in a purely resistance circuit में phi value is 0 and cos phi is 1. Power factor is 1. Similarly, purely inductor में like current and voltage ऐसे है ना. So कितना होगा? Pi by 2 and cos phi is 0. Power factor is 0. And power factor 0 है तो because cos 90, right? Cos pi by 2 is equal to 0 and power average will be 0. Right? Similarly, capacitor में current and voltage downwards. So it is also pi by 2 and cos pi by 2 is 0. So power average is also 0. Now same way उधर RL and RC भी लिख दो. RL and RC because numerical से बहुत helpful होगा भाई. RL में phi is phi only and power factor is R by Z. Okay. Now पर RL सर्किट का बोलो. Phi is phi only and इसका कितना होगा? Cos phi is R by Z, which we learn now. And similarly, R and C का भी phi is phi only, R by Z आएगा. Combination में R by Z will be the power factor. चलो, now numericals करेंगे based on this. आपको and Z you know what are the circuit under root R square plus XC square, R square plus XL square करने का. And formulas also you know, right? What is the formula? P average is VRMS, IRMS, cos phi. You know IRMS को convert करना भी आता है ना, लेकिन ओम्स ला यूज करके सॉल्व करने का, बट कॉम्बिनेशन में Z आएगा. ओके, चलो करो. I'll give options. So LR circuit is given. He told inductive reactance is equal to R. So XL is equal to R बोल के दिया है. And E is equal to E naught voltage is given. E naught sin omega t, I am giving the voltage to the LR circuit. He's telling power consumed. Whenever I ask power consumed, average power only. We know the एक ही formula है. VRMS into IRMS into cos phi. देखो peak values में है सात्विक. Peak value में you know how to convert into peak values, right? So this is V naught by root 2 into IRMS. IRMS कैसा आएगा? I naught by, और in terms of इसमें देखो VRMS by Z है ना, LR सर्क्यूट है ना, I equal V by R, Z है ना, because LR सर्क्यूट कॉम्बिनेशन में ऑलवेज Z आएगा. ऑप्शन B. ओके देखेंगे. cos phi is R by Z. ओके Z पेंड करेंगे पहले. Z का फॉर्मूला क्या होगा? अंडर रूट R square plus XL square. Here XL is also R only. So R root 2. Okay, and here also V naught by root 2 करेंगे. So V naught by root 2 into V naught by root 2 into
The
Z
C.
is nothing but R root 2. Huh?
Option
R
C.
by R root 2. और कितना आएगा? V naught root 2 into root 2 is 2. 2 into 2 4. So V R cancel. So V naught square by 4R. So here V naught is nothing but E naught only, right? Peak value is E naught. So E naught square by 4R. C is answer. So based on the options, you have to go for this one. Chalo, next one. 2.5 by pi microfarad capacitor. So this capacitance is given as 2.5 by pi. Micro is 10 power of minus 6 farads. And R value also given 3000 ohms. Resistance is joined in series of AC voltage. Voltage is given 200 volts. And peak value, right? What is this? This one is what? 200 volts means what? It is average RMS kya hai? RMS, right? What are the given RMS? Okay. 50 cycles per second. Frequency is given. Power factor is asking power factor circuit and power disparate. Dono find karo. So VRMS is equal to 200 volts. Frequency they given as 50 hertz. Asking cos phi value is how much? And power disparate is how much? Average power is how much? Since it is a RC circuit, power factor is R by Z. So आपको R by Z find करने का.
So 2.4.
2.2 no.
2.4.
No. R is given. Z का कैसा आएगा? Under root R square plus XC square. So XC find करो separately. Then substitute. XC is 1 by omega C. 1 by 2 pi F C. C is given. Pi cancel हो जाएगा. Solve करो कितना होगा?
So 5,000.
Huh?
Z is 5,000.
XC is 5,000. Now substitute in this. 3,000 whole square plus 5,000 whole square. Z only you told like 5,000?
Yes,
Oh,
sir.
okay. XC how much you got?
Sir, 4,000.
4,000. Then colors. So 3, 4, 5, 5,000 triple, right? So therefore Z is 5,000. Okay. Now substitute करो इसमें. So R by Z is how much? 3 by 5. That is how much? 3,000 by 5,000. So cancel. 3 by 5, 0.6. Power factor don't have any units. Now find karo. P average is VRMS into IRMS into cos phi. IRMS means already you know. VRMS by Z. हम सॉल्व करो कितना आएगा? हम डेसिमल में आएगा. Tell answer.
4.8.
4.8.
8.
yes, 4.8 watts. कर रहे हैं और समझे नेट में सर्च कर रहे हैं.
Doing.
VRMS is 200 into IRMS is VRMS budget. So 200 by 5000 into cos phi. Cos phi is 0.6. 6 by 10. So if you solve, we'll get as 4.8 watts. Power is watts. Okay. Next, power के बारे में average power. Whenever it says average power only. Next one is apparent power or virtual power and effective power or effective power. All are the same only. Effective power, apparent power. Whenever he mentions find apparent power, then only find apparent power. Okay. So here apparent power का formula है और virtual power simply VRMS into IRMS. खत्म. This is a formula for apparent power. If they ask, then only solve. Okay. Sure. Next topic is here wattless current. Wattless current. Wattless means what? That current does not produce any power. Wattless hai. Watt is nothing but power का, right? Wattless means no power. So simply I can tell powerless current. Powerless current is called wattless current. So they'll tell to find simply directly wattless current find करो बोल के बोलेगा. So डायरेक्ट फॉर्मूला आएगा. Okay. So देखो एक बार सपोज मान लो VRMS and IRMS current leads voltage by 5 or lags होने दो, कुछ भी होने दो. It can be RL, RC, anything में. We are general में we are trying to find wattless current. Okay. Here आपको when I take the components, what is here x component क्या आएगा? इस तरफ क्या आएगा? IRMS into cos phi. I call that as IX, x direction में. Similarly, इसका क्या आएगा? IRMS sin phi. I call that as IY. IX and IY. Okay. Now, separate calculate करेंगे. इस current is producing the power. Power calculate करेंगे. How much power is consumed by this current? How much power is getting consumed by this current? Okay. First one, IX current के वजह से. First one is IX current. How much current that is? IRMS into cos phi. Okay. Now IX current का we'll try to find power. Power का formula क्या है? P average is VRMS into IRMS into cos phi. Right, this is the formula, right? Okay, VRMS into IRMS. Okay, cos phi means phi is how much in this case में? देखो, phi is the phase difference, right? This current is in this direction and voltage are also in this direction, VRMS. So both are same direction में. Angle is how much? Phi. 0, right? 0. So I am substituting cos 0. And this IRMS कौन सा है? This one, right? IX, right? I'm talking about IX. बाद में substitute करेंगे. IX क्या है? We'll see. मान लो you have only IX current. So IX पहले डाल रहा हूँ. So VRMS, IRMS, cos phi. This is power factor. This is power factor. Okay. Here cos phi. That's why I'm putting 0. Okay. Now cos 0 is 1. Now कितना होगा? VRMS into IX is how much? IRMS into cos phi. Because some power is coming here. Whether power is 0 here? No. Matlab, this current is not producing power, not having a power. Power is there. Iska. Some current, some power is consumed here because of this current. Okay. Now we will calculate the power because of IY. IY calculate. Okay. So B wa IY के वजह से power. So P average का formula लिखो. I average, sorry, VRMS into IRMS into cos phi. देखो हियर VRMS into IRMS nothing but किसका करंट के वजह से IY के वजह से, राइट, IY, and cos phi, phi is a phase difference, it is between current and voltage, कितना होगा phase in this case में, current and voltage में it is pi by 2 90, cos 90 is 0. So that means here average power because of this current is 0. So that's why this current is called wattless current. Wattless current. So whenever they ask the formula, लिखो wattless current का definition लिखो, component of current perpendicular to velocity. Component of current perpendicular to velocity. Perpendicular voltage, velocity नहीं, perpendicular to voltage is nothing but wattless current. So wattless current का formula है simply wattless current का formula है IRMS into sin phi. This is a formula for wattless current. Because this current is not producing any power. Power is not getting consumed because of the current. Okay. तो इसका बेस पे जेईई मेंस क्वेश्चन आया करो. I'll give you options, try. In AC circuit, instantaneous voltage is given, instantaneous current is given. In one cycle of AC, the average power consumed by the circuit is and wattless current. मतलब average power भी calculate करो and wattless current also calculate. Average power formula मालूम है ना? VRMS into IRMS into cos phi. Sin phi में phase difference कितना है? Phase difference between in this voltage and current में phase difference is how much? It is pi by 4. Sin phi में pi by 4 डालने का. Okay? Phi is nothing but 45. So cos phi में भी phi के जगह में 45 लगाने का. So average power is VRMS, IRMS into
Is
cos
it
phi.
a C?
Huh? Huh?
C?
Yes, correct. So D, C,
C.
C. Okay. देखो VRMS is V naught by root 2 because we know the peak values. I naught by root 2 and phi is the phase difference between voltage and current. Voltage and current का phase difference कितना, साइन के बाजू में जो phase है that is called phase. Phase difference करो बोले तो this minus this किया तो कितना होगा, pi by 4. So cos pi by 4 is 45 is 1 by root 2. Right? Now substitute the values. V naught is 100, I naught is 20. So 100 into 20 by 2 root 2. So it is 2000 by 2 root 2. So 1000 by root 2. So इधर तो एक ही ऑप्शन है 1000 by root 2 राइट कर सकते हैं. But IRMS sin phi also you can find. क्या तो you'll get the value of 10. Right? Right, Satvik? For wattless current का simply IRMS sin phi. Phi is 45. IRMS you know. I naught by root 2 किया तो आ जाएगा. So answer in this case में 10 amperes. चलो. करो. A coil has inductance joined in series with resistance. मतलब it is a RL circuit. When a voltage 220 volts, cycles per minute, frequency is given per second. The wattless component of current is given. He's asking directly wattless component of current. कितना? ऑप्शन है अलग।
So 0.5.
तो ऑप्शन दिया तो गेस करेगा, ऐसे कर रहा है।
Must
दिखो
have
एक बार, आपको मैं डाउट लग रहा। क्या कुछ राइटिंग समझ में नहीं आ रहा क्या? हाँ ठीक है, आप करो। IRMS इंटू साइन फाइव, तो IRMS इज नथिंग बट VRMS बाई Z। सो एक्सेल कितना है, यू गॉट एक्सेल? एक्सेल इज ओमेगा एल राइट, 2 पाई FL। हाँ, एक्सेल Atlas count is IRMS into sin phi, VRMS by Z sin phi। हाँ, नो आपको इसका फाई चाहिए, VRMS by Z। So how much, tell me? Not got till now? हाँ करो करो। Z is equal to under root R square plus XL square, and XL is omega L, that is equal to 2 pi FL। Sin phi value, how much you got, Satvik? How you got sin phi?
So I did some mistake in sin phi.
See, something करेगा। Z, Z का आएगा ना, Z का कितना है, टेल में?
220 root 2.
220 √2। Okay, now I told you this is a RL circuit, right? RL circuit का diagram, impedance triangle always help whenever phi value find करने के लिए, impedance triangle will help। So देखो, this is R, XL and Z, right? XL, Z, and this is phi, right? What is sin phi from this? Opposite by hypotenuse, so XL by Z। देखो, so impedance triangle will help for finding phi। tan phi होने दो, cos phi होने दो, sin phi होने दो, I can find। So XL मालूम है, Z मालूम है, substitute here, and VRMS is nothing but that they given, right? 220 volts, substitute।
0.5.
हाँ 1/2, 0.5 अब बोलेगा। ओके आया, understood method understood?
How do you get IRMS?
IRMS is formula is what? IRMS into sin phi, right? IRMS is nothing but VRMS by Z, right? Ohm's law, and
Right,
VRMS directly they given, right?
Yeah, understood.
So if substitute will get 0.5 ampere is answer। नेक्स्ट, इसी का लिंकिंग क्वेश्चन का वन टॉपिक इज इट्स कॉल्ड चोक कॉइल। चोक कॉइल, सो जनरली चोक कॉइल मतलब सुना होगा, चोक कॉइल मींस, नहीं सुना? ओके, सी सपोज जनरली सम डिवाइस में आपको करंट को रिड्यूस करने का, सम सर्टेन डिवाइस में, सो इफ यू सिंपली अप्लाई दवर वॉल आउटपुट से, जो वॉल आउटपुट से जो मैं ऐसे देखकर मैं उस डिवाइस को दूंगा, सपोज मान लो इट इज 2 एम्पियर करंट इज फ्लोइंग, बट दिस डिवाइस रिक्वायर्ड ओनली 1 एम्पियर ओनली। सो इफ दिस 2 एम्पियर विल फ्लो, ये बर्न हो जाएगा, डिवाइस विल बर्न। ओके, सो उसके लिए आपको क्या करेगा, डिवाइस में क्या करेगा, जनरली विल पुट रेजिस्टेंस। रेजिस्टेंस लगाने से क्या होगा, वो करंट को रिड्यूस करेगा, रिड्यूस करेगा। बट प्रॉब्लम विद द रेजिस्टेंस इज वो पावर लॉस ज्यादा है, power loss is getting so much, energy is getting dissipated in the form of heat। Okay, so that is the problem with the, that's why the solution came with a choke coil। Okay, choke coil. Choke coil is nothing but a simply series LR circuit. LR coil को we call as choke coil. मतलब और simply LR circuit बोल के लिखो. LR circuit को we call as choke coil. Okay. Now इसमें L का कितना है, R कितना है, very important. L is very large. Okay. Large value of R L we are taking and small value of R I am taking. That is a choke coil. Choke coil is nothing but simply R L circuit with larger value of L and smaller value of R. उसके वजह से करंट कैसा रिड्यूस होगा, we will see. करंट कैसा रिड्यूस होगा, we will see. Without power loss. Power loss should not be there. That is a thing. Power loss हुआ तो एनर्जी लॉस हो जाएगा, एनर्जी लॉस तो करंट बिल होने दो ज्यादा आ जाएगा आपको. ओके, एनर्जी ज्यादा हो गया तो प्रॉब्लम है. तो उसको रिड्यूस करने के लिए वी आर यूजिंग चोक कॉइल. अब ट्यूबलाइट में रहते हैं, चोक गया हुआ इलेक्ट्रिशियन विल कम. ओ पुराने टाइम में दे यूज्ड टू हैव लाइक दिस ट्यूबलाइट में देयर इज ए वन इतना बड़ा एक गड्ढा जैसा रहेगा, देयर इज अ चोक कॉइल. पुराना रहेगा ना ट्यूबलाइट्स का. इफ यू सी देयर इज चोक कॉइल. ओके ओके. नाउ सी, नाउ इधर सपोज इफ आई कनेक्टेड विद ए लार्ज एल वैल्यू, आर वैल्यू. नाउ जेड क्या होगा टेल में. Z का फॉर्मूला RL सर्किट में अंडर रूट R स्क्वायर प्लस XL स्क्वायर. You tell me if L is large, XL will be large. L is large, I told, right? Implies XL will be large. If XL is large, Z will be very large, right? Very large. Now if Z is large, IRMS का फॉर्मूला क्या है? VRMS by Z. If Z is much greater, the current is much decreased. उस डिवाइस को जाने से पहले आपको करंट बहुत डिक्रीज होगा इफ यू प्लेस ए चोक कॉइल. दैट इज नथिंग बट सीरीज LR सर्किट. ओके. नाउ हियर देन व्हाट अबाउट पावर सर बोले तो cos phi इज हाउ मच. cos phi इज इक्वल टू R by Z, राइट. देखो अगर Z सो मच इंक्रीज हुआ, phi विल डिक्रीज. नाउ एवरेज पावर का फॉर्मूला था VRMS into IRMS into cos phi. ओके. सो ये cos phi भी रिड्यूस हो गया, IRMS भी रिड्यूस हो गया. सो पावर लॉस इज वेरी स्मॉल, ऑलमोस्ट approximately nearest to zero only. So that is the specialty of having choke coil. करंट रिड्यूस हो जाएगा. नॉर्मल आउटपुट दे वॉल आउटपुट से 2 एम्पियर आ रहा है, डिवाइस को 1 एम्पियर चाहिए. अगर मैं चोक कॉइल रखूंगा, करस्पॉन्डिंग कैलकुलेट करके चोक कॉइल रखूंगा, सो रिड्यूस करेगा एंड 1 एम्पियर देगा, बट विदाउट लॉस ऑफ पावर. Okay, because energy is getting not lost. Okay, these are the things in the power. Done. Power का पूरा हमारा हो गया. Now we have to enter into which circuits? RLC circuits में we have to enter. Okay, easy only. RLC. आपको individual आ गया तो we have to go for the RLC. चलो. LCR circuit. इसी में रेजिडेंस आएगा कॉन्सेप्ट. चलो. Now we are going for the LCR circuit में डायग्राम ड्रॉ कर रहा हूँ. This is L, here C, here R. I am giving the voltage. Okay. Here also I am giving the same voltage. V is equal to V naught sin omega t. Okay. Instant current में I am taking current is I. Okay. You tell me in a purely inductor में क्या होगा? Current lags voltage by pi by 2. In a purely capacitor में current leads voltage by pi by 2. In a purely resistance में current and voltage are in the same phase. Current and voltage across the resistance are in the same phase. Voltage across inductor, voltage across capacitor, voltage across resistor. They are in the same phase. Okay. Now if you draw peak values, okay. If I'm interested to calculate the peak values. देखो, net peak voltage I'm drawing. Here current I'm taking the reference. VR naught will be in the same phase. And VL naught is ऊपर है. and VC naught is down, right? This is a peak voltage. Impedance triangle also, if I convert here from this, R is like this, XL is like this, and XC is like this, right? Impedance triangle का help लेता. Now here आपको 3 different cases are there. 3 different cases are there. देखो, that capacitor, this RLC circuit में, whether this circuit will behave like a RL RC, tell me. तीनों है, कौन जीतेगा उसका it will act like. Suppose inductor is winning, okay, then we can tell it is acting like a RL circuit. If capacitor is winning, winning means reactance you have to see. Reactance XC ज्यादा है, suppose XC is greater than XL, tell me it will act like a RC या RL. XC is greater than XL, क्या होगा? RC. RC. If XL is greater than XC, RL inductor जैसे act होगा. Okay, so based on the current will be coming, lagging leading होगा based on that. That's why we have 3 cases. अगर दोनों equal हुआ तो, दोनों equal हुआ तो this and this get cancelled, right? And it will act like a purely resistance circuit, that is called as resonance. Resonance में आपको, even though physical appearance will be there, capacitor, inductor रहेगा, but voltage across the vectorially it is getting cancelled and it will act like a purely resistance circuit only. Okay, that's why we have 3 cases का. चलो, case 1, when VL naught is greater than VC naught and XL is greater than XC. Okay, now क्या होगा? tell me. I VR naught, ऊपर क्या आएगा? tell me. If VL naught is greater than VC naught, net voltage will be VL naught minus VC naught, right? ऊपर, पहले ऊपर नीचे था ना, net voltage ऊपर आएगा, right? Now the diagram, net voltage will be like this, V naught net angle phi. Here inductor is winning since XL is greater than XC. Now इधर नीचे लिखो, current lags, finally क्या होगा? It will act like RL, right? Current lags voltage by phi. So now I'm applying a parallelogram law. V naught square is equal to VR naught square plus VL naught minus VC naught whole square. So V naught square is equal to I into R naught. Okay, I naught into R naught whole square plus I naught into XL minus I naught into XC whole square. So I naught square common ले रहा हूँ, R naught square plus XL minus XC whole square. So if I take root को निकाल दिया तो V naught is equal to I naught into under root R naught square, R square, R naught बोल तो R square plus XL minus XC whole square. So देखो Z में तो क्या था? R naught plus XL था, but ये दोनों है ना, XL minus XC आएगा. Okay, so therefore I naught will be here V naught by under root R square plus XL minus XC whole square, which is nothing but I can treat as Z V naught by Z. Okay, so formula R square, मतलब आपको RLC सर्क्यूट दिया तो first try to check which circuit जैसे act हो रहा है. Based on that we can find current, everything we can find. Simply don't put lagging or leading, we don't know sir, बोल तो problem है. So XL is greater than XC, XC is greater than XL, you check. Okay, now आपको इसका tan phi क्या होगा? Tell me. If I convert into impedance triangle, this is R, this is क्या होगा? XL minus XC, and this is Z, this is phi. So what is tan phi? XL minus XC by addition is R. Impedance triangle is used to find phi. Phi कभी भी sin phi होने दो, cos phi होने दो, impedance triangle, corresponding impedance triangle we have to draw and we have to solve. Okay, चलो. Now सभी में phasor diagram लिखेंगे. What is the voltage? Tell me. ओके कॉपी राइट. हाँ चलो, सपोज मान लो V इज इक्वल टू V नॉट साइन ओमेगा टी इज गिवन टू द RLC सर्क्यूट वेयर XL इज ग्रेटर देन XC. टेल मी, आपका उस केस में करंट कितना होगा, टोटल करंट. समय RLC में मुझे टोटल करंट इज हाउ मच, ए करंट इज हाउ मच. Here XL is greater than XC, right? So it is acting like a inductor circuit. Inductor circuit में I naught sin omega t minus phi, right? It is acting like a R, inductor circuit is acting on that's phi minus phi. Lagging होगा not pi by 2 phi, right? Because RL है ना. हाँ. Tell me सादिक बोलो. Now I want purely resistance, voltage across purely resistance कितना? Current मालूम है. Current, current is omega t minus phi. Now tell me purely resistance में VR is equal to
We are not.
we are not sin.
Sine
They are in
omega
same phase, right?
Yes.
इंडक्टर में, प्यूरली इंडक्टर में
We will not sine omega t minus 5 plus 5 by 2.
minus 5 plus 5 by 2. And VC is equal to VC not sin omega t minus 5 minus 5 by 2. This is the thing. न्यूमेरिकल्स के लिए ये बहुत हेल्पफुल होगा. सिंपल, खत्म, डन. ये इसका ना सेकंड केस में जाएंगे. सो RLC सर्किट दिया तो चेक करो XL XC चेक करो, उसके अकॉर्डिंगली यू हैव टू पुट द वैल्यूज. दैट्स इट. ओके. नाउ केस 2, when BC naught is greater than VL naught. नो कैसा आएगा आपको मालूम है, करंट कैसा है, एंड VR naught and VC naught is downwards. Okay, and total voltage is net voltage and angle is phi. Now again we'll apply the parallelogram law. V naught square is equal to VR naught square plus VC naught square. Okay, okay, VC naught minus VL naught, right? Because it is acting like a capacitor circuit, right? So इधर क्या आएगा, BC naught minus VL naught whole square. So I naught into R whole square plus I naught into XC minus I naught into XL whole square. So क्या होगा, I naught square कॉमन लेंगे तो R square plus, देखो XC minus XL whole square आ रहा है, बिकॉज कैपेसिटर जीत रहे हैं ना. सो XC minus XL whole square आएगा, V naught square. सो रूट को निकाल दिया तो V naught is equal to I naught under root R square plus XC minus XL whole square. So therefore I naught is equal to V naught by under root R square plus XC minus XL whole square. It's acting like Z only, V naught by Z. And here also we can write impedance triangle. So this is R, this is XC minus XL, this is Z, this is phi. So from this, what is tan phi? Tan phi is equal to opposite by XC minus XL by adjacent R. Now लिख सकते हो वोल्टेज का, if I given V is equal to V naught sin omega t, करंट कितना आएगा? Instead this current will be, since it leads but is acting like a RC circuit phi, so I naught sin omega t plus phi. Now करंट मालूम है, प्यूरी रेजिस्टेंस में क्या आएगा, VR is equal to VR naught sin omega t plus phi. Current and voltage are in the same phase in a pure resistance में, and इसका VL will be VL naught sin omega t plus phi. करंट का वोल्टेज क्या करेगा इन ए प्यूरली इंडक्टर में, इट विल बी प्लस 5/2, राइट? प्लस 5/2. वोल्टेज लीड्स करंट बाय 5/2 एंड वोल्टेज अक्रॉस कैपेसिटर ओमेगा टी प्लस 5 minus 5/2, right? Easy. Now Now last case. Okay, when VL naught is equal to VC naught. VL naught is equal to VC naught means XL equal to XC. So क्या होगा? ऊपर नीचे कैंसिल हो जाएगा. VL naught, VC naught will be cancelled. This one we studied. R voltage across resistance VR naught. ये वाला क्या है? VL naught नीचे VC naught. If VL naught is equal to VC naught, दोनों कैंसिल हो जाएगा vectorially, and it is acting like a purely resistance circuit. So net voltage कितना होगा? VR naught is equal to I naught into R. It is acting like a purely resistance circuit. And I naught is what? V naught by R. V naught by R. Doesn't it V naught, right? Net voltage is acting like a purely resistance circuit. Just ohms, मतलब ohms का जैसा V naught by R use करेंगे. And that means here Z value कितना आएगा? Under root R square plus XL minus XC होने दो और XC minus XL होने दो. ये 0 होगा ना? ये 0 हो जाएगा. So Z is equal to R आएगा. So this is a minimum impedance in the circuit. When it is this condition को we call as resonance. Resonance बोलते हैं. इस condition को we call as resonance. Resonance में क्या होगा? Impedance will be very very less. If impedance is very very less, current क्या होगा? Current will be maximum. Current is maximum. I is maximum. Because V naught by Z, right? Z is minimum means current is maximum. मतलब at resonance में current is maximum. Current flowing in the circuit is maximum. That is called resonance. When XL is equal to, इसका impedance ड्रा किया तो कैसा आएगा? R XL XC. So दोनों की equal है. Is acting like resistance circuit. Okay, it's the impedance triangle. Now इसका बोलो कितना आएगा? If V is equal to V naught sin omega t given, since it is acting like a purely resistance circuit, omega t I naught will be I naught sin omega t only. Okay, now purely across resistance कितना होगा? VR naught sin current and voltage are in same phase omega t. तो मैं and purely inductor में VL naught sin omega t plus 5/2. And similarly purely capacitor में VC naught sin omega t minus 5/2. See how to know whether it is acting like a purely resistance inductor or capacitor means आपको XL and XC find करो. That's it. XL and XC find किया तो we can say whether it is acting like a purely inductor circuit, capacitor circuit or it is acting like a simply resistance circuit. So मेरा so these are the things. इसका questions are there and थोड़ा radio tuner बाकी थोड़ा बाकी है questions. मतलब quality factor का questions are there. Quality factor का करके ट्रांसफॉर्मर रहेगा. So maximum will try to finish by tomorrow.